Alright, so where we left off yesterday was summarizing what we've learned so far about the remainders of polynomials. So the first question is, what is the connection between the remainder when a polynomial p is divided by x minus a and the value of p of a? So the remainder is the same thing as p of a. I'll write that out. The remainder equals p of a. So if x minus a is a factor, then there will be no remainder. The remainder will be 0. And I just answered that. So we know in this case, if x minus a is a factor, then p of a equals 0. And if p of a equals 0, what do we know about the factors of p? If p of a equals 0, then x minus a is a factor. It divides out evenly. Okay, so let's go on to the problem set. I'm going to move on to the next slide here. So the first one, it says use the remainder theorem to find the remainder for each of the following divisions. So using the remainder theorem, so x minus a, in this case we have x minus negative 2. Is what gets us to a. So a equals negative 2. So p of negative 2 equals negative 2 squared plus 3 times negative 2 plus 1. So equals 4 minus 6 plus 1 equals negative 1. So we have a remainder of negative 1. Circle my answer there. For the next one, if we're using the remainder theorem, we have the x minus a, and we find p of a. So x minus 3, so we're finding p of 3 equals 3 cubed minus 6 times 3 squared minus 7 times 3 plus 9. So I get 27. 6 times 9 is 54, minus 21 plus 9, and I got a remainder of negative 39. So my remainder is negative 39. Okay, the next one, again we have the x plus 1, so our a value is negative 1, so we're going to find p of negative 1. It's just whatever, it's the opposite of whatever that is. Alright, so we have 32 times negative 1 to the 4th power plus 24 times negative 1 to the 3rd power minus 12 times negative 1 squared plus 2 times negative 1 plus 1. So we're going to get, that's going to be a positive 32 minus 24 minus 12 minus 2 plus 1. And you should end up with negative 5. So in this case, our remainder equals negative 5. Alright, let's keep moving on. Question 2 says to consider the polynomial p of x equals x cubed plus 6x squared minus 8x minus 1, and to find p of 4 in 2 different ways. So there's 2 ways you can find it. You can plug 4 into the equation. 4 cubed plus 6 times 4 squared minus 8 times 4 minus 1. So I'm going to get 64. 6 times 16 is 96, minus 32, minus 1, and I get 127. The second way is p of 4, so it's going to be x minus 4 is what I'm going to divide by. So I'm going to set up, I'm just going to use the tabular method here. I want to end up with x cubed 6x squared minus 8x minus 1. You could also use long division if that makes more sense to you. I'm dividing by x minus 4, so that's x cubed in that box, so this must be an x squared. So this becomes a negative 4x squared. and I want to end up with positive 6x squared, so I need 10x squared here. So plus 10x. 10x times negative 4 is negative 40x. I want to end up with a total of negative 8x, so this has to be a positive 32x. 32 plus negative 40 is negative 8. So this must have been a positive 32. 32 times negative 4 is negative 128. How do I get from negative 128 all the way up to negative 1? So if you think of it as a number line, there's 0, there's negative 1, there's negative 128. I had to go up 127. So my remainder is 127, which is the same thing as I got here. Number 3. If we have the polynomial p of x equals x cubed plus 42, divide p by x minus 4 and rewrite p in the form as the divisor times the quotient plus the remainder. So the divisor is the x minus 4, the quotient is the answer we're going to get plus whatever our remainder is. So I'll use long division here. Okay, and I can tell if I did part B, I'd be able to tell what my remainder was right away. X cubed plus 0x squared plus 0x plus 42. Alright, so this goes in here x squared times, so I get x cubed minus 4x squared. Okay, subtract, so I get positive 4x squared plus 0x. X goes into positive 4x squared 4x times. So I get 4x squared minus 16x. Subtract. So that becomes plus 16x. Bring down my 42. Plus 16. So 16x minus 64. Subtract. So it's 42 plus 64 is 106. So that's my remainder of 106. So it's x minus 4 times x squared plus 4x plus 16 plus the remainder of 106. That's my final answer right there. I could also find p of 4, so I just plug in p of 4 is 4 cubed plus 42. 4 cubed is 64 plus 42 is 106. And that's how I can check to make sure my remainder was correct. For number 4, is x minus 5 a factor of that function? Well, if it is, when I plug in f of 5, if it is a factor, then that should be 0. That's my thinking. Okay, so I'm going to go ahead and plug in f of 5. 5 equals 5 cubed plus 5 squared minus 27 times 5 minus 15. So I get 125 plus 25, and then 27 times 5 is negative 135 minus 15. So I get 150 minus 135 is 15 minus 15 is 0. So yes, x minus 5 is a factor since f of 5 is 0. There's no remainder. Is x plus 1 a factor of this polynomial function? So again, what do I have to do to set that to equal 0? X, we want to find f of negative 1. Okay, so I'm going to plug in f of negative 1 equals 2 times negative 1 to the 5th power minus 4 times negative 1 to the 4th power plus 9 times negative 1 cubed minus negative 1 plus 13. So this becomes negative 2 minus 4 minus 9 plus 1 plus 13. Okay, and my final answer is negative 1, so it's not 0. So x plus 1 is not a factor because f of negative 1, okay, does not equal 0. And the exit ticket. So I would like you to try this one on your own for sure, and then start the video back up to check your answer and see if you're correct. So it says, consider the polynomial p of x equals x cubed plus x squared minus 10x minus 10. Is x plus 1 one of the factors? Well, if it is, there will be a remainder of 0. And so this is, remember, we have that form x minus a. If that's a factor, so x minus negative 1 will give us x plus 1. So we want to figure out p of negative 1. And what we're figuring out is, if we plug this in, is it going to give us a value of 0? Because if it does, then it is a factor. So this is negative 1 plus 1 plus 10 minus 10. And I can see all those numbers cancel out, so yes, x plus 1 is a factor because p of negative 1 equals 0. There's no remainder. And then finally, the graph shown has x-intercepts at square root of 10, negative 1, and negative square root of 10. Could this be the graph of p of x equals x cubed plus x squared minus 10x minus 10? Explain how you know. So the hint is to write it out in factored form and then see if you can multiply the factors to get the standard form. So they gave us this p of x equals x cubed plus x squared minus 10x minus 10. Now, if those are indeed factors, then p of x should equal x minus the square root of 10 times x plus the square root of 10. I'm writing them out of order. So that's that one, and then x plus 1. So I look at this and I go, I recognize that pattern. That looks like the difference of two squares. So I could FOIL it out, or I can just use the pattern, and what I would end up getting is x squared minus 10, if I combine those two, times x plus 1, and you can put that into a tabular method box. You can FOIL it out, but what you're going to eventually end up with is x squared minus 10 times x plus 1. So I'm just going to FOIL this guy out. So first, because you can FOIL binomials, is x cubed, outside x squared plus 1, or yeah, x squared times positive 1, sorry about that, inside minus 10x, last negative 10 times 1 minus 10, and they match, yes. Okay, this is the graph of p of x. All right, let me know if you have any questions.